Hey, you with the face. I'm back again, and today on Thinking Out Loud, guys, we are going to go ahead and we are going to talk about cancer. So if you're wondering what this series is even about, well then go ahead and check out that last video that I had, which is going to go ahead and explain this channel's purpose. Since we're talking about cancer, I should probably start and explain what cancer even is, what it does, how it replicates, and why it's even so dangerous in general. A quick search on Google, if you do that, it's going to go ahead and result in a flood of information about cancer. We're going to have books, we're going to have new documentaries, and pretty much anything under the sun is going to go ahead and describe cancer and cancer's causes. But you don't need such a complex answer at this point to answer a simple question. In simple terms, guys, cancer is described as the uncontrolled division of cells. Cells in our body are, of course, replicating every day, but something interesting that isn't that common of knowledge is that the cells in our body only replicate about 45 to 55 times within our lifetime. This is known as the Hayflick limit. Discovered by the American anatomist Leonard Hayflick, this limit actually prevents cell instability. Now, this phenomenon is going to go ahead and prevent cell instabilities and abnormalities that may occur over time, because even simple processes are going to be a lot more complicated when they're replicated over and over and over again. Think about when you were 11 years old. You were 11, I was 11, we were all there once in our life. But now go ahead and think about the game Telephone. When you were a kid, you were in your, fourth grade classroom, and your teacher lined you and 50 of your closest friends all up in a line. And she gave Billy one piece of information to go ahead and pass on to Sally, who then passed it along to Jimmy. Once Billy got this information that, maybe she told him that Billy is trapped in a well. She wanted him to pass along a third person message, and then he passes along to Sally, and Pally passes along to Jimmy. Hey, Billy. Yeah, Sally? I have a secret. Hey, Jimmy. I have a secret. Just like that. Well, then by the time she gets to little George at the end of the line, George now has received the misinformation that instead of Billy being trapped in a well, Billy is actually doing well, which is the complete opposite message that we are trying to pass along. And since the body is made up of 10 to the 13th cells, 10 to the 13th, well, that can be a ton of misinformation that's going to go ahead and be passed along. And just to put that number into perspective, that is literally the number of stars in the Milky Way galaxy times 1,000. So if you ever want to finish counting the number of stars, start counting now, and maybe you'll finish in the next 2 millennia. Maybe. But just like the planets being different in the Milky Way galaxy, cells in our body all have different purposes. Well, there are cells that make bones, there's going to be cells that make skin, and cells that make brain matter. So when it comes to cancer, it's no wonder that there are so many different types of cancer as well. The National Cancer Institute has actually classified 100 different types of cancer. Now, of course, some of these cancers are going to be more problematic than others. Some cancers might relate more to Pluto, losing its nomenclature as a planet, then switching to a large asteroid, then back to a dwarf planet, which, it might seem like a big deal, but in the grand scheme of things, nothing really changed, and it's not really going to be all that problematic. But then we're going to have cancers that, based on what organ they're on, are going to pose a much larger problem. But we still haven't answered the question, how does cancer originate? Well, first, DNA must be copied with the mutation. The cell has defenses against DNA being used with the mutation, and these defenses are going to be known as pro-apoptosis genes. And these are genes that are going to go ahead and convince the cell to commit suicide when it is reproduced incorrectly. Now talk about peer pressure. Now back to Sally and her 50 friends. Well, this would be like any time one of the students passed along the incorrect message, the teacher would go ahead and come over and take that child out of this relay line and pass along the correct message once again. This is going to go ahead and preserve the integrity of the information being passed along. In this case, the children that are actually passing along the correct information that Billy is trapped in a well are going to be known as Bax genes because they are passing along the correct information, whereas children that are going to be passing along the wrong information are going to be known as BCL2 genes, which are known as B-cell lymphoma 2 genes. And these are genes that go ahead and promote cancer's growth by the overexpression of cell regulators that do not tell the cell to commit suicide when it incorporates a faulty division of DNA. So it's kind of like taking the teacher out of the classroom who's removing the children from the information relay line who are passing along the wrong information. So a quick recap, the gene that goes ahead and allows cancer to grow is going to be known as BCL2, short for B-cell lymphoma 2 genes. And this is going to be known as an anti-apoptotic or anti-suicide gene. So the cell does not die when it reproduces with a mutation. A cell that does tell the cell to commit suicide is going to be known as pro-apoptotic, or pro-suicide, also known as a Bax gene. And of course, for cancer to begin growing, the DNA or RNA must be transcribed wrong. But of course, in this example, for cancer to go ahead and be allowed to grow, the DNA or RNA which was transcribed incorrectly must be allowed to be passed along from cell to cell. So now you're going to go ahead and have some mutated DNA floating around in your body which hasn't yet fully been expressed. And this is kind of where the point in this whole cancer story, where it starts sounding like a lot like a current Marvel film which was just recently released. But even without the magical ability to regenerate the body cells an infinite number of times, the cell has a few more defenses against faulty DNA, such as mitosis in general. The spindle formation in mitosis also regulates and monitors chromosome division during the G2 phase. In non-cancer cells, if the spindle formation does not recognize the replicated DNA and chromosomes as identical, a series of reactions takes place and the cell is told to die. But of course, for cancer to grow and continue to be passed along from cell to cell, this must be overlooked and damaged or mutated DNA must stay in the gene pool. So no cancer is able to form due to this perfect storm, but what was really causing this perfect storm in the first place? And there are going to be many causes of cancer in general, but for now we're going to focus on one of the main cofactors of cancer formation. And that cofactor is going to be a gene known as P53. You may have heard of it if you've taken biology classes in college, things of that sort. But this gene regulates the cell cycle in the first place. So in order for the cell to be replicated with an oncogene or a gene that causes cancer, well, P53 must have a mutation. A mutation here is basically like converting Luke Skywalker to the dark side. He becomes just as powerful but a lot more destructive, and things kind of turn red instead of green just because it's the Jedi universe and he's a Jedi. So this gene is going to be of a lot of interest to researchers, because if this gene performed perfectly 100% of the time, well then obviously we wouldn't have cancer form and cancer wouldn't be able to continue in our society. But because there are many causes of cancer in our society, well, the actual number of cases of cancer cases that have a mutated P53 gene is more along the lines of about 50%, which is still a huge number considering that is still a ton of cancer patients that we could go ahead and cure if we cured this P53 crisis. So this P53 gene is located on the 17th chromosome in both men and women, which means that we get one copy from each parent. But when you have one faulty copy and one working copy from the maternal or paternal side, well, you're going to be much more likely to develop cancer earlier in life. Thus, we're going to have cases such as pediatric oncologists, which is just absolutely terrible, and we know that. This is something that we can go ahead and we can research now, and research is being done. It's being done out there, and I'm going to show you guys what's out there in a few episodes to come. So now that we know a little bit about how cancer works and this P53 gene, what can we do about it? Well guys, that's where the rest of this channel series is going to go ahead and take place. And we're going to go ahead and dive right in and find causes, cures, and preventative measures to go ahead and tackle these instances of cancer cases. So go ahead and stay tuned. I'm posting videos once a week, of course, as always, guys. And until the next video, if you guys are looking for something else to watch, well then go ahead and check out my video right here or somewhere along lines of here, where I'm going to go ahead and talk about the role of herbicides in cancer formation and whether or not you should be consuming herbicides at all. And as always, guys, well then I will go ahead and see you in the next video. Don't forget to comment down below if you like this video. And also, guys, talk about what you guys want to see. I'm really curious to hear from you guys. So go ahead and we'll go ahead and keep in touch down below. Well then, guys, I am out and I will see you in the next video.